Okay, so we're going to start with average rate of change. So today we're talking about average rate of change. This is your, again, I said your 2.3b. It's the extension lesson. We're going to talk about what the average rate of change is. So I filled all of this out for you, or I just screenshotted it. So the average rate of change is the measure of how much a function has changed per unit over that interval. We're going to use the words per something. So we want to make sure that when we write down our average rate of change, when we put our units in there, we're making sure that we write per unit, like 7 miles per hour. That's kind of our example. You want to make sure that you're doing per unit, okay? We're going to just use the slope formula. When we find the average rate of change, we use the slope formula. This is the y2 minus y1 over x2 minus x1. There are two examples here. Two examples. It says the average rate of change over both intervals is the, do you guys remember what that delta symbol stands for? Change, yeah, it's the change in y over the change in x. So when I look at my graph, I'm going up 2 over 2. That has an average rate of change of 1. And then they're showing you on a graph, okay? So we're just going to practice it. So our first skill is to determine the average rate of change over the interval -2, 1. This is my input. This is no different than saying what's the output when I start with x is -2 and what's the output when x is 1. So we're going to have to get that information from our graph, okay? So when x is -2, this is -1, -2, what is my output? What is my y value?
2.
+2. When x is +1, that's right here, what is my output? -7. So those are the two ordered pairs we're using. So it's saying here, hey, determine the average rate of change. Well, if x sub 1 is -2, its output, y sub 1 is 2. If x sub 2 is 1, its output, y sub 2 is -7. And I'm going to use this space right below to calculate my slope. Remember, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, I'm going to label my points. I need to label my ordered pairs. So x sub 1, y sub 1, x sub 2, y sub 2. And I know that they're labeled right here for you. They're labeled right here as well. Okay, so what value am I plugging in for y sub 2? Y sub 2 is -7. Sorry. What is y sub 1? Okay, over, what is x sub 2? And thank you. What happens when I have minus and negative? Minus and negative turns into a great big plus. So -7 and -2, same signs, add them together, keep the sign, is -9. And 1 plus 2 is, what is -9 divided by 3? So my average rate of change is -3 over 1. -3 over 1. Are we okay with that? Flip it over or inside your little booklet, and let's do exercise 2. So exercise 2 gives you an equation. So we're doing the input of -2. We're going to have to plug it into the equation for x, and then we're going to have to input 6. So this is not written as a function. It's written as a y equals. So y equals 1/2. I'm going to let x equal -2 plus 4. So what is half of -2? What's half of -2? It's -1. What is -1 plus 4? 3. Very good. So when x is -2, y is 3. Does that make sense? Okay. So someone tell me what I'm setting up for the next one. Except replace the x with a, say again, 6. Thank you. Good job. So y equals 1/2 of 6 plus 4. What is half of 6? 3. What is 3 plus 4? So y equals 7. So when x is 2, or sorry, when x is 6, y is 7. Let's use our slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. What value am I using for y sub 2? 7 minus what value am I using for y sub 1? 3 over what value am I using for x sub 2? Minus what value am I using for x sub 1? All right, 7 minus 3 is 4. 6 minus a negative, well, that minus a negative turns into a great big plus sign. And 6 plus 2 is? 8. So what does 4 over 8 reduce to? It reduces to 1/2. I need to move that little blue. So this is 1/2. Okay. Does that make sense? Let's look at a table. We're looking at the average rate of change from the interval of 1 to 6. So tell me, what is the change in y from 40 to 38? -2, right? And what is the change in x from 1 to 6? 5. So my change in y over my change in x equals -2 over 5. That's my average rate of change, -2 over 5. So I wrote that down here in my blank. Flip over. We've got a graph that we're going to look at. We're going to look at a graph. So this is what happens when you don't have a constant rate of change, right? We've seen tables before that don't have the same change in y over x. It's kind of this gridded little, the slope is different for every line segment. So we're going to answer some questions. This graph below shows a person's distance in miles walked in h hours. So time across the bottom. This is my x-axis. Miles on the vertical. That's my y-axis. Okay. So which interval do you think has the largest average rate of change? Explain.
You can typically just look at it.
And what are you looking for? Because you're right.
Goes, like, has the most change in it.
Yeah, what word did we use yesterday to describe that? We had 2 boxes. One was direction, and we drew 4 graphs on it. And the other one was, say that again. Steepness. Yeah, you're right. We're looking for the one that is the steepest.
2.5.
Well, nope, it's between 0 and 1. From 0 to 1 hour, my rate of change is 1 mile, or like 1 mile, 2 miles, 2.5. My rate of change is 2.5 miles. So 2.5 miles per hour. In the increment of 0 to 1, my rate of change is 2.5 miles per hour. What is my rate of change from 0 to 2? Or not from 0 to 2, sorry, from 1 to 2. Well, I went up 1 mile over 1 hour, so this is 1 mile per hour. That's from the 1 to 2 interval. What's happening from 5 to 6? Look at your graph. Tell me what's happening between.
They're not moving.
Good job. No movement. Their distance did not change. Do you guys see that? Their distance does not change. So, do you feel like you guys understand average rate of change?